Hey guys, and welcome back to a new video. In this video, I will show you how you can automatically test code that involves a Ktor HTTP client, specifically on Android. So if you're developing native Android apps or Kotlin multi-platform apps and you use Ktor for networking, then chances are you have or already had code that looks similar to this. So we have some sort of repository here, in this case, really just a product dummy repository that makes use of this dummy API. So if we take a look at the URL here, then you can see it really just gives a fixed response of dummy data so we can test this whole thing. Of course, in a real app, this would be your real API that you talk to. But then here in your repository, you maybe have some code that actually executes the real request. In this case, it's a GET request. You maybe catch some exceptions. You then check the status code of the response. So if it's larger than 400, that means it's either a client-side error, so bad request, not found, so something that is the client's fault. Or if it starts with a 5, that means it's a server error. But either way, it's an error. That means we can't really fetch any data. And in this little bit simplified example, we will just return an empty list right away. Of course, in a real app, you may want to pass these errors around somehow, pass it to your view model, display them to the user or so. But to show you what I want to show you, this will be totally enough. Then afterwards, we just fetch the body. So we take the JSON response that I just showed you, and we parse that into such a product DTO here. So really just the raw response here represented as a Kotlin data class consisting of product DTOs. Here in this simplified example, we really just care about the ID, title, and description. In the API, a product is way more complex, but in order to test this whole thing, we really don't need all this product data here in this sample code. And then lastly, we simply return those products and we map them to a domain level product. So in real project, you also typically would have a dedicated function to do that, and you would just call it.toProduct or so. But here, since we have just a single function, I did this directly in the repository itself. This is now code we want to write test cases for. If you want to follow along with this video, then I will also share the GitHub link down below with this initial code where you can then follow along and add the test code. But I will also include a link to the final testing code after this video. But first of all, we need to understand what we want to test here and in which scenarios what I teach you in this video actually applies. So you can see in this repository, we pass in an HTTP client. That is a dependency, that is a class that comes directly from the Ktor library, from Ktor networking. And this allows us to just fire off these requests. Now, there are two scenarios on Android where it makes sense to actually work with the so-called Ktor MockEngine. So Ktor MockEngine is in the end just kind of an extension or replacement for the real Ktor engine that we pass in our production code that allows us then in our test cases to define which API request should now respond with which response. So we just simulate an API response, and then we want to see, okay, does our code actually handle this specific response in the right way? And this makes sense on the one hand if you want to test your repository implementation in isolation. So you want to test this class here, which is the real implementation that you use in your production code. So you want to test this logic here in your repository functions. Then watching this here makes sense. Or alternatively, if you are into integration or end-to-end testing, so you want to test multiple parts, multiple classes of your entire app working together, then it also makes sense to watch this. Because with integration and end-to-end testing, what many people actually don't know, you want to replace as little dependencies as possible in your test cases. So very often we have those so-called test doubles, where you maybe write another implementation of your repository that serves as a so-called fake that just simulates the behavior of a repository, but then you suddenly don't use the actual production repository's logic anymore. So if we have a bug in this Ktor product repository and we use a fake version of this repository in our code, for example, for this product's view model, which I will explain in a moment, so we pass in a fake version here, then this helps us to test this product's view model in isolation. But if there is a bug in our Ktor product repository in the actual production implementation, well, then that previous test case won't catch it. That is why we typically want to have a mix between unit tests, integration tests, and end-to-end tests. And in those integration and end-to-end tests, we really just want to replace the boundaries. So where communication really leaves the process of our app. So that means talking to a REST API, then that REST API HTTP client would be something you want to replace in an end-to-end test. Something like a local database implementation. The local database would be something you replace in a test case. If you have something like you're talking to maybe a hardware sensor or so, then that's technically also something where communication leaves the device, because you are talking to some kind of other process in the Android OS. Because in the end, if a test case in our Android app fails, we want to be sure that there is an issue in our code. If we now rely on the real HTTP client and talking to our real API, making real network requests, then it can of course be that there's some kind of network issue, that the backend has issues, there can be latency issues, and then our test case will fail because of an issue that is not in our code. And that doesn't help us. That will just require us to look into the code just to find out it's not us. So that is why it's desirable to just replace the last possible dependency so that we can still test everything of our own system, of our own app, without actually also including those external components like a REST API. And since this Ktor product repository really is just internal to our app, communication here only leaves the device via this HTTP client, which we can replace for the test case. But if we replace it for the test case with a MockEngine, well, then communication suddenly does not leave the device anymore, so it's totally fine to use this implementation, the production one, in our test cases. All in all, what I will show you here is I really just have a very basic sample setup, so you can see creating this HTTP client here works via such a factory. Those of you who've watched my courses, specifically the Android Essentials bundle, will know this. So just a simple create function that takes in this HTTP client engine, which would be the, for example, the CIO engine or OKHTTP engine for the production code, but passing this in here as a function argument allows us to then, of course, pass in a different engine for our test code. So this factory really just has the responsibility to configure this HTTP client, return this here in this function, and then in our product view model, which has the responsibility to initiate those API calls from the repository, and then finally update UI state in order to show these loaded products, for example, in the UI. Here we then rely on the product repository, so this is just put behind an abstraction, so there's an interface, and the implementation of this interface is then this Ktor product repository. And in this product view model, we really just have a product state, so a mutable state flow, which keeps all the products here in a list. And then once we start subscribing to this product state, so this would happen and would be executed once the UI calls something like collect as state with lifecycle or so, then if we haven't already loaded the products, we will load them, we will populate our products state flow, and we say, okay, now we already loaded them, so they won't be loaded again after resubscription, which could, for example, happen if the activity rotates or so. The app would then resubscribe to this flow. Since we already loaded the products previously, we can prevent reloading them via this simple if check. So now I want to test two things here. On the one hand, I want to test that if our API, so making the request to this endpoint, actually responds with valid data, that we also get this valid data here in our product view model, so that the product state flow keeps the correct data after making that HTTP call if it was successful. And on the other hand, I want to write a test case that makes sure that if there is an error in the API response, so we try to load data, but it responds with some kind of error code, that this products list is also empty after all. So this in this case would be a typical integration test, because multiple classes of our project here are tested together, multiple parts of the project, in order to make up a valid end-to-end test. The UI of the app would typically also be involved here. But here in our case, we don't need any UI, which is why I haven't implemented that. But let's actually get to the juicy stuff and start writing the test case. For that, we actually want to test something in the view model here, because that is where we also run the assertions on, whether this product's stateful here actually has the right emissions after making those API requests. So how does this work? We want to hit Alt-Enter here, and then want to create a test case. Something I haven't told you yet in unit test is that we added some dependencies here. So on the one hand, of course, the Ktor dependencies, but also this Ktor client mock dependency, which is included in the initial code that I link down below. Turbine, that is a library that makes testing flow emissions much, much easier. AssertK is my favorite assertion library for Kotlin. This is optional, but I will stick to this one. And the Coroutines test library, which just comes with some utility that makes it easier or possible in the first place to properly test coroutines related code, because that's obviously something we make a lot of use of if we work with such REST requests. You can see we have multiple suspending functions here. We have real flows here in which coroutines are involved. So we definitely need some extra utility there. But we now have our product view model test class. So this is now the class where we want to type our test cases that automatically should later on check whether our code still works as expected. So what always comes first when writing a test case? We first of all need to construct the dependencies, so the class instances that we actually want to test. So in the first place, we need a private latent variable for our view model. Our view model, in order to initialize that, we need a product repository. So let's create that next, private latent variable repository, which is our Ktor product repository or product repository directly. Since we explicitly want to test this production dependency, I will also make the type of that to kind of enforce having to create this and not accidentally using a fake instance here or so, because as I said, that is really not what we want. We want to test as much of our production code as possible while not having this this risk that our test case fails because of some external circumstances. We also, if we want to create this Ktor product repository, for that we need this HTTP client. So we also need an HTTP client here we create in order to pass this then to our product repository. This is just a Ktor HTTP client now. And well, in order to create our HTTP client, we don't really need anything. We do need to pass in the HTTP engine, but you will see in a moment how this works. In test cases, once we've declared those dependencies, we want to initialize those in the so-called before function. So this before function, which is typically called setup, this will simply run before every single test case in this test class. It's generally a good idea to always reinitialize all dependencies in the setup function here. So they are always reinitialized before every single test case, just to avoid that maybe one test case mutates some kind of internal state of one of these classes, which another test case then uses, fails because another test case has mutated that state. That's something we don't want. We always want to make sure that we start with a completely fresh setup for our test cases. So we reinitialize those classes beforehand. First of all, the HTTP client. We want to initialize this with our HTTP client factory. And here it becomes important that we actually have this factory because the core configuration of this HTTP client always stays the same. The only thing that differs is this engine, which is where we pass this in, but the rest here really stays the same. So make sure to add such a factory to your code. So we want to create this HTTP client here where we now have to pass in the engine, for which we want to use the MockEngine. This comes from the Ktor Mock library, which we've included previously. And if we pass this here and say MockEngine.create with this block of code, then this will successfully apply this MockEngine. This code we will leave empty for now. We will change something about that in a moment. And first of all, go on with our code. So now that we have our HTTP client, we can use this to initialize our repository. So we say Ktor product repository, and we pass in this HTTP client. With this repository, we can then say we initialize the view model, so products, view model, and pass in this repository. And then, now that we have this view model instance successfully initialized, we can already start creating the test case. Because this is in the end the instance we want to run the assertion on. So we want to kind of simulate a request. We want to simulate that this request to our endpoint returns the valid product list, so returns this JSON data here from the browser. And then we make sure that after making this request, in our view model, this product state flow actually contains exactly that list of products that we've previously loaded from this JSON response. That is in the end what we want to test here. So we can go down, we can say we have a test case here annotated with test, and this is a function. We can also name it with backticks here. That's typically something I like to do because it keeps those test cases very, very readable. And since we also don't call these in our own, that's something the testing framework JUnit in this case does. That will be totally fine here, and it's a common practice. So for example, what the test case could be called like is products are correctly loaded for a successful API call. That is something we could do here. Because if we see this in our little testing tab that will show up once we run the test case, so here, for example, if we run it for a blank setup, this will always pass unless something crashes, of course. And yes, that was also what happened here. So something crashed because of the setup function, but that doesn't matter because all I wanted to show you is this testing tab here where all of our test cases will then be shown. We can see whether they failed, whether something crashed in them, whether they passed. And with this text here, with the function name, we can immediately see, okay, if something failed, we know what failed and where to possibly look for the issue. That is why the naming for test cases really matters here. But what we now want to do is, we in the end want to say view model, that products, that is what we want to test. And with the Turbine library that I've included previously, so the flow testing library, we can now simply say test. So we have some kind of flow, in this case a state flow, and we want to test this. You can notice that this test function complains because it's a suspending function and it can only be called from a coroutine or another suspend function. Here, we are not in a suspend function. So what do we do typically in test cases? If we want to call a suspend function in a test case, well, one option is to call run blocking. This way, the entire suspending functions here within this test will all run sequentially, which is usually something that is desirable for tests. Because if you have a lot of stuff that happens in parallel, you have multi-threading, then this multi-threading thing itself can mess up the test case again, because if you have a race condition, then the test case sometimes fails, sometimes passes. That's not a very good foundation for a test case. So if you're testing stuff that involves asynchronous programming, always make sure to bring this into a synchronous flow. So everything in your code should be executed on a single thread. So race conditions can't happen. That running the same test case 1,000 times will always lead to the exact same functions being called in the exact same order 1,000 times. What we can now do in here is, we could first of all say we have the initial emission, because that is the first thing that we expect from this products flow. If we take a look in here, the very first emission is obviously just a default state, so an empty products list. That is something we can already get here by saying await item. Works because we are here in this test scope, so we can await for an item. This will suspend this test case until the next emission of this product state flow arrives. For the initial emission, this will be pretty much instantly, so we can already run our assertion on that by saying assert that our initial emission is actually empty. So we just make sure that the initial emission here must be an empty list. We don't yet have any products. However, if we now actually execute our request, so in our Ktor product repository, we call this client getCode. We make the request here to this endpoint. We load this JSON data. We parse this from JSON into our data class, first of all, with Kotlin serialization. We then use this. We map it to a list of products. We update our state flow with this list of products. On this whole path, a lot of things can, of course, go wrong. And that is really what we want to test here. So the next thing that we would expect from this test case, if it was successful, so if it passes, is that the next emission, so our loaded products, which is then the next await item call, so the second emission, that this one actually, for example, has a certain size, that there are real elements in this list. So we can say, when I assert that the loaded products have a specific size of, and if we take a look at our response here, it actually says that down below. So there are 194 total products, but this request is limited to the first 30. So this list that was loaded here contains 30 products. That is now what we expect and what we want to assert on. And of course, you could also go a step further with this. You could assert on the actual product data that was loaded, that each product was properly parsed, that the title is actually the same title from the JSON, that the description is the same, and so on. I think you get the idea. In this case, I just make sure that we really loaded the right amount of products in our JSON response, in our code here. However, you will notice, of course, that's probably no surprise to you, if we run this, then this will still fail because it has no request handler provided in MockEngine config. Because right now we just test and we assert on this product state, but we don't have any code in our test case that actually says, now execute that request. And what this response should most importantly look like. Because the request is technically actually executed the moment we subscribe to this products flow here. So here, the moment we subscribe to that, this onStart operator is called. And if we haven't loaded products yet, which will always be false for the first time, then we will actually call this repository getProducts function. So this will be executed already, but the test case currently fails because here this block is still empty. Since the way this Ktor MockEngine now works is, inside of this block, we can now define a so-called handler. So we can say we have a handler, we add this here, we get the request, and depending on the request, we can now add our own custom logic, which specific response we actually want to return for that, just for our test cases. So this has nothing to do with our production code, but we can say for our test cases, we can, for example, check the relative URL, which is equal to request URL encoded path. And then we can say, when that relative URL is actually /products, if our real code, if our HTTP client that uses this MockEngine under the hood makes a request to the relative URL /products, then we can now say, okay, if that's the case, respond with this specific response in our test case here. So we can give this response a content. Well, the content should in this case be our successful response. So this JSON string here, just select everything here, copy this, go back to Android Studio. And for that, I actually want to create a little utility class, because while we could, of course, put this in a constant, pass this here, then this content would simply apply to all test cases here in this class. But maybe we want to have different responses for the same endpoint across test cases within the same class. In order to support that, we actually want to go to our test source set here and simply add something like data and HTTP util or so. On the one hand, we want to have a products responses object. So this will simply be a singleton that just keeps our JSON responses for various different use cases, for various different types of requests here just in an isolated class. So we can say we have a valid response. We can create such a string here with triple quotes and then simply paste our JSON code in there. So this way we have an easy way to just reference the successful JSON response that we get from the real API to make this as close to reality as possible. And of course, if you have different types of valid responses or different types of error responses, this is the place where you can also add these as separate strings. Another thing that I will do is I will go in our HTTP util package and I will create something called an HTTP response data. This will be a simple data class which encodes the combination of, on the one hand, the content in form of a string, so what a specific response should contain as a content, so the JSON string, and on the other hand, the status code, which is an HTTP status code. Because that way, in our product view model test, we can create an instance of this, so private var should be mutatable. We call this response data, create an HTTP response data here, and by default, we say, okay, this returns our product's responses, that valid, so by default, we return the valid JSON response together with the status code of HTTP status code.ok. So this is just the default response that we use. So we can now take this response data object here in our handler, and for the content, we return the response data.content. For the status, we return the response data.status code. And if you want, you could also pass in some headers. You could also make this dynamic by including the headers here in our HTTP response data class. If all of your code or all of your API routes purely return JSON, then you probably don't need this because we can just create these headers here on our own, and we can set the content type header, for example, to application JSON, so that this is the header the API will respond with, or at least our simulated mock API. And well, since in our case, this is the only relative URL that we actually make calls to, we can just say, in all other cases, we respond with something invalid. So we can say the content is an empty string, and we say the status is something like HTTP status code.not found. So this route wasn't found in that case. So we will just see the issue in our test case. And we could also say something like not mocked or so. So it's even clearer in our test case that if this is the response, we will see, okay, it's actually an issue here directly in the code and not in our actual production code. Of course, if you have multiple requests to the same endpoint, like a GET request, maybe a POST request, and so on, this is something you should check in addition here. I think you can also see this here from the request method. So you could check if the request method is actually HTTP method.post, for example. If that's the case, and you make it to a relative URL of /products, well, then you can return the post response data. Otherwise, the get data. I think you get the idea. In our case, we'll just have a single request to a single endpoint with a single response. So I will stick to this approach. So let's actually rerun our test case. We run this, take a look here, wait a little moment, and it actually passes. Interesting. So this definitely means that our API and our logic and our code works as expected. And whenever something like this happens, that a test case passes, what I personally love to do is I apply a technique called mutation testing. Mutation testing means that you intentionally break parts of your production code that should be covered by your test case in order to see if the test case really catches that issue. So it's kind of a test case for your test case. And this is something we could do here, for example, in the Ktor product repository, where we say, okay, we actually have a typo here. We make this request to the wrong endpoint. Would our test case catch that? Yes, it would, because now it says, okay, no value produced in 3 seconds. So what that means with Turbine is that here in our test case, a wait item suspended for at least 3 seconds, no item was returned. So that means there was no second emission here in this flow, which is why the test case failed, just because we intentionally broke the production code. Of course, make sure to revert that change. But Just do this here and there for your production code, break a few things, maybe swap out the return statement, swap out the larger equal with a less equal, change a plus to a minus, and see if your test cases really catch those issues. Because trust me, it happens much, much more often than you think, that you think your test case is actually testing something, but under the hood, it actually just tests some kind of fake dependency, a fake class from your test suite, which is then successful because all your assertions run through. But since nothing of your actual production code is tested, it can still break without the test case catching that, and then the test case is obviously worthless. However, that was only one part of the equation with this test case. Now we've tested the happy path, that everything goes right, but as you probably know, in the real world, things don't always go right. What happens if we want to test the case that our API responds with an error? Then we need another test case here. So we say we have a test case, and we say function with backticks, and we test something like an API error returns empty products list. Products. Something like this. We again say run blocking. We again want to assert on our view model product state. So we say that test. We again assert on the initial emission or initial products, whatever, that is equal to a wait item. We make an assertion on that the initial product is actually an empty list. But now, the interesting part comes now. We want to make sure that after this initial emission, there are no more other emissions. Because if there was an emission where the list suddenly has a size of 30, for example, then this would obviously not be intended if our API responds with an error. And this is something we can also easily test with Turbine by saying expect no events. So after having the initial emission, we want to make sure that there are no more events that we did not process with Turbine, so that we forgot to call a wait item for. And of course, what we need to do is we need to kind of tell Ktor and its mock engine what kind of error we want to return, and that we want to return an error in the first place. And that is, again, where our response data class comes in handy here, because we don't need to change anything of this mock engine logic, but rather we can just say response data is equal to HTTP response data, and we just reinitialize that class here, so that the next API call will just reference this new response data. So the content here in this case could simply be, and the status code could be something like HTTP status code forbidden, for example, which is 4.3, which means in our Ktor product repository, we would expect that this part of the code here actually catches that, returns an empty list, and this empty list is then applied to our state flow. So the default value won't be changed. This actually won't be treated as a separate new emission, because state flows have this behavior on Android, on Kotlin in general, that if we try to set the value of a state flow to the value it was before, then nothing will be emitted. We won't get this emission here of another empty list inside of this test block. That is why we need to assert this via expect no events. So we say, okay, no more emissions are actually coming in here. If we run this, let's take a look here. This actually passes. So are we done? Not really. Let's again apply mutation testing a little bit. And let's, for example, say we comment out this HTTP response data and we rerun this test case. You will notice the test case still passes, even though there is no place anymore where we told our mock engine that it should return an error. Why is that? Of course, the initial product emission is always empty. That's also the case for successful response. But didn't we add this expect no events assertion here? So that if there are no more events, that our test case actually breaks? Well, we did, but testing coroutines and flows on Kotlin is very tricky. The thing is, we currently don't control any bit about the execution of our coroutines here. And it could be that those coroutines that are involved here in our code are actually relying on background threads under the hood. And if we launch a background thread inside of a test case, even very deep down in our code, so for example, the mock engine does that and launches a separate thread, then our test case has no idea that this thread exists in the one hand, and it also won't be able to wait for this thread to finish executing so that there is a valid, that our Ktor product repository's code really ran through. And since at this point of time, where we call this expect no events, there is really no other event in this test block here that still has to be asserted on, so the test case will simply pass, while there is still maybe some code in the background that still needs to be fully executed. And the way to fix this and work with this is just a custom test dispatcher that you should always use and rely on when testing coroutine related code. And this is really just a super quick masterclass on coroutines testing. I have super detailed premium courses about that. On the one hand, the Mastering Automated Testing of Android apps, and the Kotlin Coroutines and Flows Masterclass, in which I both cover testing, because this is really tricky. The details really make a difference here. I will link those two courses down below. But here, just in short, we want to have something like a private val test dispatcher. We initialize this with unconfined test dispatcher, so this will always automatically launch all involved coroutines. We hit Alt-Enter here to just opt into this experimental coroutines API. And then, on the one hand, we need to say dispatchers.setMain, and we set our main dispatcher to the new test dispatcher. And in our tier down function, so the function that gets called after every single test case, we want to say dispatchers.resetMain again. So what this achieves is we have our custom dispatcher that allows us to control the coroutine execution in our test cases, and we replace what was previously the main dispatcher with the test dispatcher. So that means, for example, in our products view model, here where we launch this flow and cache it inside of view model scope under the hood uses the main immediate dispatcher. So that's also pretty similar to main. If we replace that, that means this will use our test dispatcher under the hood instead of the main one. If we run this again, then we will notice that, well, our test case still passes. Because another place where we need to swap out the dispatcher is our MockEngine. And luckily, the MockEngine allows that. So here, inside the MockEngine create block, we can set the dispatcher here to test dispatcher. And that way, our Ktor client, so wherever a Ktor client executes a suspending code here, this suspending code will surely be called on our test dispatcher. And since all of the coroutine-related code that we execute here is now executed with this test dispatcher, we fully control the execution of that in our test case. So our test case also knows when there are still certain coroutine tasks being executed, like, okay, there's actually still an API call going on here, a simulated API call, so I better wait until I make this assertion, while it would not be able to tell that if we would rely on dispatchers.io, dispatchers default, dispatchers main or so, because all those dispatchers could technically launch background threads, except for the main one. So if we now rerun this, we should see a failing test case, and we do see a failing test case, because if we take a look here, we expected an empty list, but we got a valid products list, so our assertion failed. In order to now correctly test this, we of course need to uncomment this again. So we now say we really return this forbidden error. And now if we rerun this, then our test case actually passes because an error results in an empty list being returned here in our repository. So there are really no more emissions in our view model. So I hope this really showed you again how important this mutation testing is, which can also actually apply to mutating your test case itself. So you saw that we just changed this to a successful response, so to the default response data, and it simply passed. But now that we are sure that our test case tests the correct thing, we could again go into our Ktor product repository and say, okay, we actually only return an empty list for responses that are larger than 500. Then the test case would probably still pass if we run this. So this would require some more assertions. But this code path in this case would not be executed. It would be another path. There would not be any valid data that could be parsed, so it would probably enter this path here. Since there is no JSON, it couldn't parse that, so it also returns an empty list. Something like that, but if we would throw an exception here, then this would probably be caught by our test case, so we do this right now. No, actually seems to go through a different code path here, but whatever. This is really something I would keep on doing here in a real project. You would typically not just return an empty list, but there would be some way to let the user know that something went wrong. You would maybe pass down a specific error code that lets the view model know what went wrong, and then you typically assert on that error code. So in that case, you would also have much more clarity on which code path actually failed, and then this mutation test that I just showed you would make more sense. But as you can see, testing on Android can be incredibly complex, where we have unit testing, integration testing, end-to-end testing. We have UI testing. We have instrumentation testing on an Android emulator versus local unit tests. We have all those classes involved. We have HTTP clients, databases. We have all those Android SDK-specific stuff like testing permission requests. So much that has to be learned here if you really want to master this topic. And I think this video alone has already shown how complex this can be, which is now maybe 30 minutes long. So guess what you get in a 10-hour course together with the 7-hour Coroutines and Flows Masterclass course, in which we really deep dive into these topics. So after watching through this course, you go out there and you say, you know what, colleagues, we are going to write some test cases. Here's how we do it. And they will be grateful. So links to those courses are below. Thanks so much for watching. Happy learning. And I will see you back in the next video. Have an amazing rest of your week. Bye-bye.